Okay, we're just continuing with our notes. We left off in example 1. So our notes were multiplying polynomials, and factoring quadratics. So basically what we did so far was we were multiplying two polynomials together to get a trinomial. And today what we're going to do is we're going to take that trinomial and we're going to divide it back into those two factors, or those two polynomials that multiplied to give us the trinomial. All right, so that brings us to the topic of factoring a quadratic. And for our sake, we're just going to work with trinomials today. Next year in Algebra 2, we'll work with larger than trinomials, so maybe 4 terms, 5 terms, and so on. But now we're just going to go with 3 terms, which is what trinomials are. Okay, so what it means to factor means to divide it back into two polynomials. So divide into two polynomials. So you're basically going backwards from multiplying. Okay, so the first one that we'll do, I think it's the exact same problem that we worked on. Let's see, where did I see that one? Oh, maybe I'm lying. Give me 1 second. Oh, I'm going to give you this one, and we're going to work back to that, and I'm going to show you how we get that. All right, so we're going to take 35x squared minus 11x minus 6. And our directions here now are to factor. Okay, so when I look at this, in order to factor this, I basically want to say to myself, I'm going to get this back into the two polynomials that were multiplied together to give me this trinomial. And there's a couple ways to do this. Okay, so the first way is to look at factors of 35 and 6. Factors of 35, factors of 6. I ignore the signs because otherwise you're going to have like double the amount of factors. For example, negative 6, it's like 2 and 3. It's a negative 2, positive 3. Or a negative 3 and positive 2, right? So you would end up with like double the number of factors. So I just put it as all positive and then I worry about the signs later. So factors of 35 are 5 and 7. And it's also 1 and 35. I list all of them. Factors of 6 are 2 and 3, and 1 and 6. Okay. Now, if you remember, our first terms here have to multiply to give us our first term, right? So that's FOIL backwards. So I need to either have 5 and 7 here, 5, 7, or 7, 5, or I need to have 1 and 35, or 35 and 1. Okay, so those are my first two terms. Those make up my F's in the FOIL. And then my last two terms, so these two right here, those multiply to give me this negative 6. So I'm either going to do a 2 and a 3 and a 2, or a 1 and a 6, or a 6 and a 1. Okay, and then the signs that go here will determine the signs of that number. So you know that if you have a negative as your last term, one of these would have to be positive, one would have to be negative. All right. So from here, I just think to myself, well, what are some what are some ways that I can put factors of 35 here and factors of 6 here, and then have my inners and my outers end up giving me a total of that negative 11x. So that's what our question is. All right, so a couple ways that you can do this. You can come over here and you can start multiplying. So if I take 7 and 2, that's 14. And then 5 and 3, that's 15. And so I would add them, they'd get to be 29, or I'd subtract them and I'd get 1. I'm looking for 11, so that's not going to work. Maybe I switch them around. How about 7 times 3, which is 21, and 5 times 2, which is 10. So 21 minus 10 will give me 11. So I'm actually going to, I believe that these two things will work right here. So I'm going to use the 7, and you've got to have an x because it was x times x, which would give us 35x squared. And then I said that 7 would need to be multiplied by the 3. So I'm going to put the 3 here. And then that means that the 2 and the 5 have to go together. Now this is where I'll try and figure out my signs. So my inners so far are giving me 10x. My outers are giving me 21x. In order to get negative 11x, I need to have a negative 21. Well, which of these would make my outers be negative? That's correct. This 3 here needs to be negative, and this 2 needs to be positive. So now you can go through and you can double check everything. So first terms multiply, I get 35x squared. Last terms multiply, I get negative 6. And as we've already shown, my inners are giving me 10x. My outers are giving me negative 21x. And that gives me a total of a negative 11x for my middle term. So this would be the factored form of this, right? So we're taking that polynomial, that trinomial, and we're dividing it into two polynomials, or in this case, two binomials. There's more ways to think about doing this. So another way is to go backwards on that area model. So you knew that you had 35x squared here. And you knew that your last term had to be negative 6. So then what you can do from there is you can find factors of 35. So for example, I can take 35x squared, and 5x. Or if those didn't work, the 1x and the 35x. And then I can also take factors of 6. So 2 and 3. So let's see, let me mess this up for you a little bit. Let me go, okay, how about if I put a 3 there and a 2 there, and I'll make this a negative 3 and this a positive 2. I'm just guessing here. Okay? So then when I say, well, negative 3 times 5x, well, that's negative 15x. And 7x times 2, well, that's 14x. Notice when I combine these, do I get my middle term of negative 11x? I don't. Therefore, I would know that I was wrong. So I would say, oh, okay, those middle terms are not working out for me. Again, I don't put the signs in until the very end. And I'll switch them. I'll say, how about a 2 and a 3? So here I would get 21x. Here I would get 10x. And then I say to myself, well, I need a negative 11x. Therefore, this one would have to be negative, meaning that the 3 would give us a negative. So this is 5x minus 3 and 7x plus 2, because that gives us our positive there. And then the 2 and the negative 3 give me that negative 6. So that's using your area model. And then you'd rewrite it just like this, 7x plus 2, which is that like length. And then the height here, which is 5x minus 3. Okay. Another way that some people have thought of doing this is to take, let's see, can I think about how this is done? You take 35 and you multiply it by 6. 35 times 6 would give you a total of, let's see, 210. So then you take 210, so I'm giving you multiple ways of thinking about this. And how do I get factors of 210 that'll give me a middle term of negative 11? Well, if that's the case, I know that 210, factors of 210 are 21 and 10. And again, I would want my negative 21 and my positive 10. So then I basically go to, I'm right back to this, right? I know that my inners and my outers need to be negative 21 and positive 10. Or that would really help you on this area model. You would know that this box should be negative 21x and this box should be positive 10x. And that'll help you figure out which factors you should be using for both your first and your last terms. All right, so let's do some more examples of this. So this is probably one of the most challenging. This is where your coefficient of x squared is not 1. So we'll start off with an easy one. So we'll do this as example 2. We're going to do factor and check. There's no reason to ever get these wrong. You can always check by going back through and remultiplying the polynomials. All right, so the first one we'll do could be x squared minus x minus 42. So this is a nice easy one because the coefficient of x squared, which we usually call a, and we'll talk more about that in our quadratic formula when we start talking about quadratic formula. But the coefficient here of x squared is 1. So when you think about finding the factors of your first terms, here, 35 had several factors. Here, the factors of my first term are just 1 and 1. So it's pretty simple. So basically it's just going to be x times x. So I don't have to worry about like the 7 and the 5. Which makes life a little easier because all I'm thinking about is 42. I'm looking for factors of 42 that when I add or subtract them, I'll get 1. Well, factors of 42 are like 2 and 21. Add or subtract those, you don't get 1. Let's see, 1 and 42. Add or subtract those, well, you get 43 if you add them. You get 41 if you subtract them. Not going to work. 14 times 3, right? So add them together, you get 17. Subtract them, you get 11. So far not working. I'm looking for a middle term of negative 1 or 1. Okay, and of course I saved the right one for last because I just wanted to kind of prove a point. So I add those, I get 13. But if I subtract them, I could get negative 1 out of that. Okay, and like I said, I always wait on the signs anyway. So really, I'm just looking for a 1. Okay, some of you guys have seen it again with these like diamond problems. So in your past, you said, what are factors of 42 that when I add or subtract them, I'll get negative 1? And then you would say to yourself, yep, 7 and 6. And you'd probably go through a mental process like this. And then you'd say, oh, I need negative 1, so 7's got to be negative. All right, so I can go through now and I can factor this into two binomials in this case, where my first two terms, right, that f of FOIL, have to multiply to give me x squared. So that's an x and an x. And my last two terms have to multiply to give me 42. So that's 7 and 6. And my inners and my outers have to add up to give me negative 1, which means that my 7 will be negative and my 6 will be positive. Okay, so to check this, oops, and that's negative 1x. To check this, you can go back through and you can do FOIL. Or why don't we go ahead and use a little area model here to check. So I have x minus 7, and I have x plus 6. So when I multiply, I get x squared, a negative 7x, a positive 6x, and a negative 42. And so these two right here would multiply to give me that negative 1x. So I end up with x squared minus 1x minus 42. And that does check out with what I originally started with. So the factored form is this right here. Two binomials that if I went back through and I did FOIL or I did double distributing would end up giving me with what I exactly started with. All right, let's do another one. How about we'll do x squared minus 14x plus 24. So another example of where your coefficient of x squared is 1. So that makes this a really easy problem. You're really just looking for factors of 24 that will either add or subtract to give you your middle term, which is 14. Because the factors here are just going to be 1x and 1x. So I can start off right away factoring this into two binomials, and I'm going to have x's as my first terms. Now let's try and figure out, using 24, what are some factors of 24? Well, 6 and 4, 8 and 3, 1 and 24, 3 and 8, Oh, I already did that. Sorry. I'm not going to double that up. 2 and 12. So which of these can I add or subtract to get 14? Well, if you add those, you get 10. You subtract them, you get 2. Add those, you get 11. You subtract them, you get 5. Right? Again, I'm kind of ignoring the signs for a few minutes. Okay? Or some people would like to write that using these diamonds, saying, hey, I've got positive 24. What are factors of positive 24 that will add or subtract to give me negative 14? And maybe at this point you're saying, Frisk, this is really easy. It's going to be 2 and 12. And what would have to be true about both of those signs? Well, they're both going to have to be negative. So right away I'll know that these are, let's see, I'm going to put 2 and 12 here. Now I'm going to work with my inners, which is 2x, and my outers, which is 12x. And then what do I need? I need to get 14x, but I need a negative 14x. And as we said over here, that would make both of their signs negative. And then this is a great way of checking. So you can do the area model, or another great way of checking is just to say, hey, my first terms now, give me x squared. And my last terms now, give me positive 24. That's another way that you can check this. Your last term will only be positive if both of your signs here are exactly the same. So they either both be negative or both be positive. Okay, so I checked it. This right here is actually my answer. That is the factored form of the trinomial, right? It's broken up into two things that I'm multiplying together. The x minus 2 is getting multiplied to the x minus 12. All right, let's make this a little bit more challenging. So let's do 8x squared minus 56x plus 48. So one of the things that you always want to look for when you're doing these problems is to see if all the terms in your polynomial, in this case a trinomial because 3 terms, if they have any common factors. Because if they do, then you can divide it out and make your numbers smaller to work with. Usually in your favor. So that may be like, for example, in this case, I won't have a coefficient anymore of x squared other than 1. Okay, so I notice that 8x squared, 56x, and 48 all have a common factor of 8. So I can, we call it factoring it out, or it's the same as like reverse distributive property. So the first thing I'm going to do is I'm going to factor out a greatest common factor. All right, so I'm going to factor out an 8. Leaving me with x squared, right? Because 8 times x squared is 8x squared. 8 times negative 7x is negative 56x. 8 times positive 6 would give me that positive 48. So it's reverse distributive property. I pulled out something that all the terms had, which was the greatest common factor. And then I just think to myself, 8 times what gives me the first term? 8 times what gives me the second term? And 8 times what gives me the third term? Now, the part that I need to factor, 8 is already factored out, but this trinomial right here can still be factored. So that's what I'm going to work on factoring. So I'm going to keep the 8 where it is. This trinomial will get factored into 2 factors, 2 binomial factors. We're back to an easy problem because my first term has a coefficient of 1, meaning that it's just going to be x times x. And then, of course, this gets really easy because I'm just looking now at factors of 6. That'll give me 7. Well, my only choices for 6 are 6 and 1 or 2 and 3. Well, 6 plus 1 will give me 7. So I'm going to use 6 and 1. Checking my inners, I get 6x. Checking my outers, I get 1x. How do I make that into negative 7x? That's right, they both have to be negative. So it's a negative 7x, which means both signs here are negative. which is why my last term is positive, right? -6 times -1 gives you positive. Okay, and then just checking my first, I get x squared. My inners and outers I've already checked. My last, I get +6. Do that. If you're not going to do that on paper, which you're supposed to be doing that on paper, but if you're not going to, then you're going to also need to make sure that you're doing it in your head, because it's really, really ridiculous for people to miss these problems. Okay, so I'll just go through and show that I did it. So that gives me an x squared here, and then this gives me a +6 there. So this checks out. You put a little check mark. I know that you checked your work. And this is the completely factored form. Okay, so let's do another more challenging one. D. So this is 1. We got 10x squared minus x minus 2. So again, notice my coefficient of x squared is 10. It's not 1, so it's going to be a little bit more tricky. I got to find factors of 10 and factors of 2 that will add or subtract to give me 1. Okay, so one way that I do that is I come over here and I say to myself, what are factors of 10? What are factors of 2? So we got 10 and 1, 5 and 2, 2 and 1. Okay, and I don't worry about the signs again, because otherwise you'll have double the amount of factors. So you'll just have more numbers you got to mess around with. And then I just sit there and I combine these. So I distribute in a way. So I go 10 times 2 is 20, and 1 times 1 is 1. Well, 20 plus 1 would give me 21. 20 minus 1 would give me 19. So that's not going to work. What if I switch it around? What if instead I do 2 times 1, which is 2, and 10 times 1, which is 10? Well, 10 and 2 will either add to give me 12 or subtract to give me 8. Not what I'm looking for. Okay, so now I'll come down. I'll say, you know what? 10 is probably not going to work. Or 10 and 1 is not going to work. Now let me try this with 5 and 2. So if I multiply 5 times 2, I get 10. And 2 times 1, I get 2. Okay, so 10 and 2, you can add them and get 12. Subtract them and get 8. That's not working. So now let's switch them around. 2 times 2 is 4. And 5 times 1 is 5. Okay, so let's see. 5 and 4, if I subtract them, I get 1, and that's what I'm looking for. So I know that I'm going to use these. The factors of 10 will be my first terms, and the factors of 2 will be my last terms. So breaking this up, factors of 10, x squared will go here. So 5x and 2x, because those are my first terms. Factors of 2 now, I need to make sure that the 2 gets multiplied by the 2. So the inners, right, will give me that 4x. And then my other factors of 2 is 1. So my outers here will give me that 5x. And I want to end up with a -1x, which means I need a -5. So that's a -1x. And in order to get the -5, the outers need to multiply, which means that it's going to be a negative on the 1, because the 1 is the outer term. The inner terms are positive, so this sign gets positive. Okay, now from there, I can show you a couple more ways to do this. So some people, instead of breaking it up like this, what they'll do instead is they'll do a diamond, and they'll multiply these two terms together. And they'll say to themselves, what are factors of -20? That'll multiply and then add to give you -1. Okay, well, what are factors of -20? Well, it's going to be -5 and +4. And I got those here by, so because after this, you're still going to have to figure out, well, how do I get these numbers? Right? My inners or my outers, sorry, had to give me -5. My inners had to give me +4. So I actually prefer doing it this way, because I have all the numbers separated, all the factors separated that are going to go into all 4 spots, right? The first spots, the last spots, the inner spots, the outer spots. And then I can check this. using an area model. Or you could then come from, maybe from here, for example, you know that you need a negative 5x and a positive 4x to give you that negative 1x. You know that your first terms have to be, let's see, 10x squared. That needs to, right here, be 10x squared. And you also know that your last term has to be negative 2. All right, so then I can say to myself, well, if this is going to be 10x and this is going to be 5x, well, then this will probably be 5x. This part right here will probably be 2x, right? So that gives me that 10x squared. Okay, then 2x times what will give me 4x? Well, I'll have another 2, and that's going to be positive. 5x times what will give me this negative 5x? Well, that's got to be a negative 1, so I got 2x minus 1 here. And then that should make this be negative 2. So that's kind of another way to think of it. You can use this diamond problem along with this area model to kind of break it up. And then once you get there, you can write it out into the two factors. Either way, this is your final answer.